Good morning, everybody. Welcome to part 8 video of ZYNQ Ultrascale Plus and PetaLinux. The title of this video is nVidia Jetson AGX Xavier SPI Interface and using Xilinx ILA. These videos are in parts supported by Blickfeld company. They create LiDAR. They are here in Munich. The LiDAR they create, it has a very nice level of accuracy and performance, and they are available to be purchased. The agenda of this video is first we talk about the SPI interface on Jetson AGX. Then we briefly talk about the ILA, which we have in our vivado projects. And then we run a test, a practical test, in which we run an application on Jetson AGX, and at ZYNQ side, we try to capture the SPI signals using ILA and see if they look correct or not. So here is our setup for these videos. And the one interface that we are basically trying to test right now is this interface between Jetson AGX Xavier and ZYNQ. This is a closer look at this interface. We have the pin header, the 40-pin header of Jetson AGX at one side, and then we have the P-mode connector of ZYNQ at the other side. And these wires you see here, one of them is ground, the black one, and the other ones you see, they are SPI interface signals. Basically the clock, slave select, MOSI, and MISO. And in our test, Jetson AGX is SPI master, and as I have shown you, ZYNQ is SPI slave. For the 40-pin header of Jetson AGX, if you look at the document nVidia Jetson AGX Xavier Development Kit Carrier Board Specification, section 3.3, then you can see a default arrangement for the pins on the 40-pin header. And the pins that we are interested in are basically the pins related to SPI1. SPI1 MOSI, that's an output from Jetson. SPI1 MISO, that's an output from ZYNQ. SPI1 clock, and then SPI1 slave select 0. Now, there exists also SPI1 slave select 1. That basically means Jetson AGX can have two different SPI slaves. And each of these slave select signals, or let's say chip select signals, goes to each of these SPI slaves. For our setup, we have ZYNQ as the only SPI slave in our setup. Important point is when you open up the Jetson AGX, when you set it up, when you install Jetpack on Jetson AGX, then by default, the SPI pins are not enabled. You need to enable them yourself. Basically, the pin multiplexer unit inside the SoC should be configured so that those pins I showed you in the previous slide get connected to the SPI controller. As we will see, there's an application on Jetson that we can run. Its name is Jetson IO. And this application helps us to enable those SPI pins very easily. One other point which is very important and you should consider is the voltage of the IOs for Jetson AGX and for ZYNQ. As you have seen, I have connected the Jetson AGX to the P-mode connector of ZYNQ, and from there I know that I'm going to a high density IO bank, and high density IO banks in ZYNQ Ultrascale can support 3.3 volts LVC MOS signaling. I/O voltage levels I'm using for this test are basically 3.3 volts, and it's important that you check your Jetson AGX and you make sure that the I/O voltages for the IOs on the pin header are 3.3 volts. This is basically a jumper at the back of the board. Now, as I described to you on my Jetson AGX, I'm running Jetpack 4.4. Here is a snapshot of the device tree which is being used on Jetson AGX right now. Jetson AGX has many SPI interfaces. I think it has at least 6. Out of the 6, one of them is the one that we will use. And that guy is this SPI interface at this address. As you can see here, the device tree by default has entries for 2 SPI dev, SPI slave devices. The device tree is indicating that through this SPI interface, Jetson AGX can have 2 generic SPI slaves. So we have these 2 entries, SPI 0, SPI 1. This is the guy which corresponds to chip select 0. This is the guy which corresponds to chip select 1. All I need to do is to make sure the pins on the pin header are really connected to the SPI controller. Now when we run Jetson IO, then the device tree gets modified, and those pins in the pin header, basically the corresponding pins on the SoC, get enabled and get connected to the SPI1 unit. This is the PinMux section of the device tree, and as you see, these pins are enabled and they are going to be used for the SPI1 SPI controller interface. Now if you don't understand the device tree part completely, don't worry, we will repeat this again in near future at ZYNQ104 site, because as you remember, in our setup, ZYNQ104 is the master for Z board, and as I will show you, a very similar setup should be done at device tree in ZYNQ104 site, so that we can have Xilinx Xi Quad SPI block enabled and to allow it to perform SPI transactions towards the Z board. Okay, so now for continuing these videos, I'm gonna record 2 screens. The first screen is the default one I have been always recording. The second one is the Jetson AGX screen. So before I continue with Jetson AGX screen, let's have a look briefly at what we want to do in our test. This is the ZYNQ104 vivado project. We have this block here, my Xi SPI slave DMA. This is a DMA capable Xi SPI slave device. We talked about this briefly in previous videos, and this guy has a SPI slave interface, and the SPI slave interface is basically connected to that PMOD connector I showed you in the photo, and SPI signals will flow over this interface to our design. They enter the Xi SPI slave block, and also they enter the System ILA. We have a System ILA here with which we can monitor the SPI signals. What does System ILA do? System ILA acts like an oscilloscope for me. It acts like an oscilloscope which is installed inside the chip. So with this guy, I can monitor the signals inside my design. It has a buffer inside, a buffer created by block memories, which are the usual resources of the FPGA. Now, when a trigger comes, System ILA starts recording the signals into that buffer. And then later, through JTAG interface, I can read the contents of that buffer and display the waveforms. Basically, it captures for me the waveforms, and then later through JTAG interface, I can read those captured data and display them.